So moving forward with chapter 8, the next thing we want to look at is what happens when projects have different scales. So if you have a project that has, if you have two projects, for example, that have the same IRR, but one has an initial investment of 1 million, and another has an initial investment of 100 million, even though both has the same IRR, really we cannot compare them on the basis of IRR. We cannot say that both projects are really the same because I'm making 10% money with only $1 million in investment, but it is taking me $100 million to make that same 10% return on my investment. So in terms of the fundamental question, where am I getting the biggest bang for the buck? Obviously, I will get it when I'm using lesser capital. So for example, we look at a project like this, has an initial investment of $10,000, followed by $6,000 cash flow. So I can put this in cash flow format, C0 negative 10,000, C01 6,000, F01 would be 3, and then I can calculate net present value. Net present value comes out to be 4,411. I is 12%. Over here, I have $10,000 investment, followed by $5,000 cash flows. And similar, I get net present value of 2,209. Now these two are comparable because they have the similar, doesn't have to be exactly the same, but similar in scale. One is not, let's say, 2 times, 3 times higher than the other. I can compare them on the basis of net present value. I can compare them on the basis of IRR. So you can see that the blue line and the red line, they track each other. They're very parallel to each other. So at a cost of capital of 12%, the girlfriend's business has a higher net present value, and that business also has a higher IRR. So they're very comparable, and they're comparable because they have similar scales. But if they did not have similar scales, right? If they did not have similar scales, what would happen? I'm going to skip over this crossover computation over here, which is also in your textbook. I'm going to skip that. You don't have to be responsible for this. I'm going to skip over and go right into the section where we are talking about how do we evaluate projects that have significant differences in scale, not the example that we just looked at. What if there were differences in scale? So let me go over an example over here. So let's say I have these 1, 2, 3, 4, 5, 6, 7 projects that I'm evaluating. And I have to select one of them. And I find out the net present values of the 7 projects, and I find out that this project has the highest net present value. If everything else was the same, and I did not face any capital constraints in my firm, meaning I could borrow money, I have an unlimited capacity to borrow money, then this project would make sense because I am adding the most value to my company. I'm adding the highest value to my company. But if I'm facing a capital constraint, which theoretically I shouldn't, but practically I do. So if I'm facing a capital constraint, then what should I do? Well, then I should calculate what is called the profitability index, where I take a look at net present value and I divide it by how much money does it take me to generate this net present value. In other words, I reorder my projects on the basis of what we call profitability index. And why do we do it? Because I'm going to be measuring how much value I am creating for every dollar of resource that my company or my project is consuming. For every dollar of resource consumed, how much value do I create? And of course, in a colloquial sense, we can talk about it this in the sense of this, which project gives me the biggest bang for the buck. If I use that metric, and I go back to this example over here, then I would take that 110, divide that by the initial cost of the project, which is 200. And this would be approximately 0.5. If I take a look at, let's say, project G, this would be 35 divided by 40, which would be close to 0.9. Right? That means for every dollar that I'm spending over here, I'm adding almost 90 cents of value for G. However, for C, for every dollar that I'm spending, I'm only adding about 50 cents of value. So from a profitability index, so this will give me my profitability index, this one, project G, would be a superior project compared to project C. So anytime we are faced with resource constraint, whether it's human resources, whether it's capital resources, whatever, then we should reorder our projects. We should select our projects not just on the basis of net present value, but on the basis of profitability index. And in the examples, when you review the tutorial examples, you will see there are several examples that we have worked out on this one, how to calculate profitability index. The last thing we are going to look at is how do you evaluate projects that have different lives, or what we also call unequal lives. So the example that we are working out over here is an interesting one. They are not just projects with unequal lives. We're comparing project A with project B. They not only have unequal lives. Project A has a life of 3 years, project B has a life of 2 years. So really, I cannot directly compare them. Project A has an initial investment of minus 10 or $10, followed by further negatives. So what does this project look like? This project is like a investment followed by maintenance. So I'm looking at, let's say, a network server that requires $10 million of investment upfront, or $10,000 of investment upfront, but I have to spend $1,000 each year for maintenance. Another competitor comes in and says, it will only take you $7,000 upfront investment, but you will have to spend $2,000 going forward in terms of maintenance. And oh, by the way, this project is 3 years, this project is 2 years. The contracts are different time. How do you evaluate which one is a better choice? We can do the net present value method. So C0 minus 10, C01 minus 1, F01 3, I equals 10, compute net present value, we get minus 12.49. Repeat the same process for B, we get negative 10.4. If I only select them on the basis of net present value, then B is a superior choice. Why? Because it is the least negative. Thus, on a timeline, on a number line, 10.47 is high, negative 10.47 is higher than negative 12.49. So these are cost projects. We are only expending money. So we want to select the one that is the least negative. So B would be the superior choice. But would it be the right choice? Would it be even fair to compare A with B? And the answer is really not, because A has a 3-year life, B has a 2-year life. I really cannot compare them. How do I resolve this dilemma? I resolve this dilemma by using the following technique. I calculate net present values. Let's say I'm going to be sticking with 1 first. I calculate the net present value of 1, of A, and choose in my time value of money calculator, present value 12.49. that project A has an N of 3 and IY is 12. Based on these input, which is the same input that we used when we did net present value. Right? So I take the net present value as given, I input these numbers, and I compute payment. I compute payment. What am I actually computing? I'm essentially asking the question, if I have a present value of negative 12.49, what will be the year-to-year annuity? What will be the year-to-year annuity that will give me a present value of negative 12.49? So I do that, I enter that, I compute the payment, and I get numbers 5.02. So my expenditure per year, meaning this 12.49 of negative cost today, translates into a per year cost of $5,000 approximately. I repeat the same thing for project B, and I find out that the per year cost of project B is $6,000. So now on the basis of what we call equivalent annual annuity, and these payments are exactly that, they're equivalent annual annuity. First of all, they're annuities. They're the same over years 1, 2, 3, or 1 and 2. Second, they are annual. And number 3, they are equivalent. They are the annuity that gives me my equivalence to this net present value. So that gives me my equivalent annual annuity tells me that on a per year basis, I'm spending less with A than I'm spending with B. So the right choice in this case would be A, not B, because it has the lowest cost per year for this particular project. So we are faced with calculating equivalent annual annuities anytime we are comparing 2 projects or 3 projects that have unequal lives, that have different lives. Then we have to translate them into equivalent annual annuities through this 2-step process. Step 1, we calculate net present value. Step 2, we calculate equivalent annual annuities or payments. So step 1, calculate this net present value using your cash flow keys. Step 2, take this net present value as given and calculate the per year payment. And these per year payment would be considered equivalent annual annuities. And you can then look at other examples of calculating equivalent annual annuities, for example, here, and practice some more of these programs. And I think, let me just quickly look at this, and over here you have a summary of the different rules. Review this, gives you a definition, what does the rule do, advantages and disadvantages of each, net present value, IRR, payback, and profitability index. We've studied 4 different rules, and we have to understand under which circumstances are we going to use what rule. So that completes chapter 8.